Hey class, in today's lesson we're going to talk about rational exponents, which is found in section 6-4, part 1 of your book. Our objective is to use rational exponents. Alright, so it's asking in the beginning, where it's kind of posing to you, what is a rational exponent? So in general, the nth root of x equals x to the 1 over nth power. So like the radical form, the exponent form indicates the principal root. So for example, the square root of 36 is 36 to the 1/2 because within the radical, it's really to the first power, and that's square root. So really, it's whatever the number is on the inside. So the radicand, it is that power on the inside over whatever the root is. So again, if I'm looking at the cubed root of 64, it's really 64 to the first power on the inside, so 1/3. And then the fourth root of 16 would be, again, 16 to the first power on the inside, so 1 over 4. Okay, and so we'll do that multiple times. So let's look at our first example. In example 1, it says, what is the simplified form of each expression? Okay, so first we're actually just going to start by trying to find the simplified form. So 216 to the 1/3, first I need to write in radical form. So 1 would be the power, and 3 is the root. So when I rewrite this is the cubed root of 216. I'm going to say cubed root. All right, so let's go ahead and break down 216. Okay, so 216 is 2 and 108. 108 is 2 and 54. 54 is 2 and 27, and 27 is 3 and 9, and finally 9 is 3 and 3. So in the inside of cubed root, we have 1, 2, 3 2s and 3 3s. If it's cubed root, we're doing triples, so a 2 and a 3 will come out, so your answer is 6. So 216 to the 1/3 power is 6. Okay? Let's take a look at the second one. I need to erase this work. All right, 7 to the 1/2. Remember, the numerator is the power, the denominator is the root. Okay, so this is really the square root of 7 times the square root of 7. We know because they have the same root that they can be put under the same radical sign. So the square root of 7 times square root of 7 obviously is squared. So your answer is 7. And finally, again, the numerator one more time is the power, the denominator is the root. So this is going to be the fourth root of 5 times the fourth root of 125. They can be combined under the same radicand. So it's 5 and 125. 125 is 5 25s. So let's break that down. That's 5 25s. And 25, of course, is 5 and 5. So in total, we have the 5 from the beginning, right? And then the 125 is 3 more 5s. Since this is fourth root, we're going to take all of them, so our answer is 5. All right, let's go ahead and practice with our try. All right, so again, the numerator is the power, the denominator is the root. So this is the square root of 64, which we know is technically plus or minus 8, or you can just write 8 for this example. All right, again, this is the square root of 11 times the square root of 11. We know that that will equal 11. And then finally, this is the square root of 3 times the square root of 12. Remember to break down 12. 12 is 2 and 6, and 6 is 2 and 3. So this is the square root of, bring down that 3. We have another 3 from the 12, and then 2 2s. I should have put those in order, but I didn't. Anyways, take them out, and our answer is 6. All right, let's keep going. All right, so we have a key concept. So it's basically just going on to tell you now that, you know, your numerator won't always be 1. Sometimes it is a number. And remember that number is going to be the power within the radicand. Okay? All right, so here you go. So we're changing this to radical form. Okay, so x to the 3/7. X is what's going to go on the inside. Okay, the numerator is the power. The denominator is the root. So this is the first answer. So the 7th root of x cubed is the radical form of x to the 3/7. They mean the exact same. They're just written in different forms, okay? The second one, however, I think it'd be easier to see if we wrote negative 3.5 from decimal form to fraction form, okay? So just in case we've forgotten how to do that, negative 3.5, that should be negative 3 1/2, right? We wouldn't want to see it in mixed form. We'd want to see it in, okay, that's a 3, sorry. We'd want to see it in improper form. So 2 times 3 is 6. 6 plus 1 is 7. So this is negative 7/2. All right. So your numerator, well, first of all, let's go ahead and do this. This should really be 1 over that, right? In order to make that positive. So instead of 1 over, let me rewrite this. Instead of this being y to the negative 7/2, we're going to rewrite this as 1 over y to the positive 7/2. Okay, and then that 7/2, remember the numerator is the power, the denominator is the root, so this is really going to equal 1 over the square root of y to the 7th. Okay, so again, the first step we did was change the decimal to a fraction, specifically a mixed number. Then we changed that mixed number to a improper fraction, okay, and then we rewrote. All right, let's do the second set. So now we're changing from exponential form to radical form, or excuse me, from radical form to exponential form. So again, the numerator is the power, so our base is a, the numerator is the power, which is 5, and the base, or excuse me, the denominator is the root, and the root is 2. So our answer here is a to the 5/2. Okay, now here we have a little bit of a different setup. You can think about it as 2 different ways. You can think about this originally as b, the power on b is 1, and then the root, the root is 5, right? And it's being raised to the 3rd power. And remember, when you raise a power to a power, you're multiplying. So that's 1/5 times 3, which is b to the 3/5. Or you could see that since the b is 1 here, just go ahead and say that it's 3/5. So b to the 3/5 is your answer. The way I initially did that problem is the way you should do that problem, just in case the power on b is not 1. All right, so again, we're changing to radical form. So this first one, we have w to the negative 5/8. Let's go ahead and change this to a positive power. So this would be 1 over w now to the positive 5/8. Okay, and then from there, remember the numerator is the power within the radical. And then the 8 is going to be our root. All right, so this is really 1 over the 8th root of w to the 5th. All right, 0.2, that's really 2/10, right? That's 2/10, and if we reduce that, that's really 1/5. So this is really x to the 1/5. So remember, draw your radical. This is x. The power is 1, so we really don't have to write the 1, and the root is the denominator, which is 5. So it's the 5th root of x is our answer. All right, look at the second one. It says, what is the exponential form of the following? So the 4th root of y cubed. Remember the power. Write your base, which is y. The power is the numerator. The denominator is your root. So this is y to the 3/4. And again, we should rewrite the second one in the following steps. Z to the 1/5 raised to the 4th, which still is going to be z to the 4/5. And we're done. One more problem. All right, so it says Kepler's third law of orbital motion shows how you can approximate the period P in Earth years it takes a planet to complete one orbit of the sun. Use the function below where d is the distance from the planet to the sun in astronomical units, which is about 93,000 miles, or the distance from the Earth to the sun. And so it says, how many Earth years does it take Mars to orbit the sun if the distance from the sun to Mars is 1.5 astronomical units? So remember, AU is actually our distance, and we know that because it said it here. It's a distance from the Earth to the sun. So the 1.52 that we're going to we're going to substitute as d. So P will equal 1.52 to the 3/2. Okay, honestly, this is just a calculator problem. So if we type that in, you would type 1.52, use the caret symbol. So 1.52, caret symbol, parentheses, 3, and then divided by 2. And then once you press enter, your answer is going to be about 1.87. So it's about 1.87 Earth years, or it'll take Mars about 1.87 Earth years to orbit the sun. All right, so let's try the next one. All right, so here it says find the approximate length in Earth years of each planet's year. So again, we're just typing these into our calculator. So instead of 1.52 like we had on the last problem, these are now going to be their respected years. So this would be P, and I should write in white. So P is going to be equal to 0.72 to the 3/2, and that is about 0.61 Earth years. And the last one, P equals 5.46 to the 3/2, and again that's about 12.76 Earth years. Alright guys, that's it. Remember, as always, if you need any help, come see me for tutoring.